This video is about a review for solving trig equations. Number 1, solve the equations on the interval 0 to 2 pi. Give a general formula for all solutions. For A, we know this is a linear pattern. So we need to isolate the variable on one side. We move all variable on the left side and number the other side. Cross the river, change sign, so we got the 5 tangent x minus 4 tangent x equals -7 plus 6. Combine like terms, we got the tangent x equals -1. We know reference angle. That's pi over 4. Since tangent equals -1 less than 0, we go to second and fourth quadrant because all students take calculus. For second quadrant, we know 3 pi over 4. For fourth quadrant, we know that's 7 pi over 4 because of this pattern. Then we need to check angle. This is x. So we know x equals 3 pi over 4 and x equals 7 pi over 4. x1 equals 3 pi over 4. x2 equals 7 pi over 4. We need a general form. Period, that's pi over b, because this is a tangent. And we got the pi over 1 equals pi. B is the number beside the x. So we can write down the general form. That's 3 pi over 4 plus pi times n. 7 pi over 4 plus pi times n. And n is integers. This will be the general form. Now let's go to second question. Still, we need isolate the variable on one side because this is a linear pattern. This is equal sign. Cross cosine to the right side. I got -2 square root of 2 equals 9 cosine x minus 5 cosine x. We got 4 cosine x equals -2 square root of 2. Then I need to divide it by 4. We got the cosine x equals, reduce, you will get -square root of 2 over 2. Then we go to reference angle. This will be pi over 4. Since cosine is a negative, therefore we go to the second and third quadrant. Then use this pattern, write down the angle. That will be 3 pi over 4 and 5 pi over 4. Then we need to check the angle. This is x. So x equals to these two angles. You will get x1 equals 3 pi over 4 and x2 equals 5 pi over 4. For general form, period equals 2 pi over b. The number beside x is 1, So 2 pi over 1 equals 2 pi. Therefore, I can write down 3 pi over 4 plus 2 pi times n. Then 5 pi over 4 plus 2 pi times n. Then n is the integers. For number 2, solve the equation on the interval 0 to 2 pi. For C, we know this is a power pattern. Keywords still isolating. So I move -1 to the right side. I got 3 tangent square x equal to 1. Then I divided by 3 both sides. Then we will get tangent square x equals 1 over 3. Do square root both sides. Don't forget plus or minus. Then you will get the tangent x equals, for a over b, square root of a over b, we can do square root of a over square root of b. So square root of 1 over 3, you will get square root of 1 over square root of 3. You will get 1 over square root of 3. That will be square root of 3 over 3. So we got plus or minus square root of 3 over 3. Reference angle, that's pi over 6. So we go to quadrants now. We got 1, 2, 3, 4 because it's a positive and a negative. That's all cover the all quadrants. Then we can write down the angle for each quadrant. This is pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Therefore, x equals pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. This will be the solution for C. Let's go to D. Sine square x equals 6 times 1 minus cosine x. Remember, when you solve the trig equation, make sure it's the same angle and also the same trig. For D, we got the same angle. This is x, here is x. But it's not the same trig. You need to change sine square into 1 minus cosine square, because cosine square plus sine square equals to 1. Therefore, for sine square x equals 1 minus cosine square x. Therefore, I got the 1 minus cosine square x equals distributive property. I got 6 minus 6 cosine x. Then check the pattern. This is a quadratic pattern. Remember, equal 0, that's the keywords. When you do the quadratic pattern, make sure ax squared plus bx plus c equal to 0, and a must be greater than 0. Therefore, I will move cosine square x to the right side. Everything to the right side. I got the 0 here. When you move, make sure it's this pattern. Therefore, I got the cosine square x minus 6 cosine x plus 6 minus 1. Combine like terms, I got the cosine square x minus 6x plus 5 equal to 0. Then you need to go to Ninja X. 5 negative 6 over 1 over 1. 5, I can do 1 times 5. Multiply, get a 5. But adding get 6, we need a negative 6. We put a negative 1, negative 5. Your variable will be cosine x. So I put the cosine x, cosine x. Then you do bottom up. You will get, this is a 0, cosine x minus 1, and a cosine x minus 5. Then I need to set up cosine x minus 1 equal to 0, and a cosine x minus 5 equal to 0. Then I got cosine x equal to 1. 0 pi over 2 and a 3 pi over 2. We know cosine 0 equals 1, so that's x equals to 0. That's the answer. We put the x1. For this side, I got the cosine x equal to 5. Since cosine x, the maximum value is 1, so there's no solution for this side. Since I'm looking for the angle between 0 to 2 pi, 0 over here also 2 pi. So you can write down x1 equal to 0, x2 equals 2 pi. This will be the solution for D. Now let's go to E. Same thing, we need to make sure the same trig. So we know the cosine square x plus the sine square x equal to 1. Therefore, cosine square x equal to 1 minus sine square x. So I change cosine square x into 1 minus sine square x equals distributive property 3 sine x plus 3. Distributive property here, I got 2 minus 2 sine square x equals 3 sine x plus 3. This equation is a quadratic pattern. Therefore, try to make equal to 0. And a must be positive. Therefore, move everything to the right side. You will get equal 0 on the left side. I got the 2 sine square x plus 3 sine x. Then 3 minus 2. Then combine like terms. I got the 2 sine square x plus 3 sine x plus 1. Then go to Ninja X. You will get the 2, this is 3, over 2 over 2. 2, I can do 1, 2. Multiply, get 2, adding, get 3. That's the paired factor we are looking for. So here's 2, this is 1. Reduce, you will get the 1, 1. The variable, that's the sine x. Sine x. So we do bottom up. You will get the sine x plus 1 and 2 sine x plus 1 equal to 0. Then I will set up sine x plus 1 equal to 0 and 2 sine x plus 1 equal to 0. We got the sine x equal negative 1. Since this is a -1 minimum value, supposed to be only one solution. We know sine pi over 2 equals 1, therefore sine 3 pi over 2 equals -1. Therefore, your x1 equals 3 pi over 2. For this side, cross the river, then divided by 2, you got -1 over 2. Reference angle, that is pi over 6. We go to third and fourth quadrant because this is a less than 0. Therefore, I got 7 pi over 6 and 11 pi over 6. We can write down solution x2 equals 7 pi over 6. x3 equals 11 pi over 6. That's the solution. Now let's go to F. Remember, when you solve trig equation, make sure it's the same angle, same trig. But same angle, that's the priority. We have 2x and x. Suppose this is the angle x, 2x will be here, 2x. Therefore, for 2x and x is not the same angle, you have to use a double angle identity to change into same angle. Since for sine 2x, that's only one formula we got to use. 2 sine x cosine x. That's for sine 2x equals to sine x. For sine x cosine x, we still call this is a quadratic pattern. So first step, you have to get equal to 0. Move sine x to the left side. I won't get equal 0. Therefore, you got the 2 sine x cosine x minus sine x equal to 0. Then I find the common factor, that's sine x. I got the 2 cosine x minus 1 equal to 0. So I set up sine x equal to 0 and 2 cosine x minus 1 equal to 0. For sine x equals 0, you go to this axis angle. We have 0, pi over 2, pi, and 3 pi over 2. Since sine 0 equal to 0, therefore you have 0 and a pi. So we got the x1 equal to 0 and x2 equal to pi. For second one, I need to add 1 both sides. So 2 cosine x equal to 1. And cosine x equal to 1 over 2. We know reference angle, that is pi over 3. Since cosine is positive, we go to diagram that go to first and fourth quadrant. So we got pi over 3. This is 5 pi over 3. Therefore, you got x3 equals pi over 3 and x4 equals 5 pi over 3. So this will be the solution. For x between 0 to 2 pi. Now let's go to J. First of all, you have to make sure when you solve trig equation, we have the same angle. We know that for x and 2x, they are not the same angle. Therefore, you need to change 2x into x. For cosine 2 theta, we have 3 formula for you to change. But which one is best? Always make sure we have the same trig when you solve the trig equation. Since we already have a cosine x in the equation, therefore we choose the second formula to use. So for cosine 2x, I got the 2 cosine square x minus 1 plus 4 cosine x equals to negative 3. Then we know this is a quadratic pattern because we have a cosine square and also cosine x. Then we need to get equal to 0. Make sure that ax squared plus bx plus c equal to 0 form and a is a positive. Therefore, I need to move negative 3 to the left side, get equal 0. I got 2 cosine square x plus 4 cosine x minus 1 plus 3 equal to 0. Combine like terms, we got the 2 cosine square x plus 4 cosine x plus 2 equal to 0. Since we have common factor that's 2, which means we can do divided by 2 for everything for this equation. And we will get cosine square x reduce plus 2 cosine x plus 1 equal to 0. Then we go to ninja x. 1, here's 2 over 1 over 1. For 1, definitely we only do 1, 1. So we got here's 1, 1. And a variable that's cosine x. Cosine x here. Bottom up, you will get the cosine x plus 1 and also cosine x plus 1. Basically, we need to solve only one cosine x plus 1 equal to 0. Cross the river, then we minus 1. We got the cosine x equal to negative 1. For cosine x equal to negative 1, only one solution. Since cosine 0 equals to 1, then cosine pi equal to negative 1. Therefore, x equals pi. This is the solution for this equation. When x between 0 to 2 pi. Now let's go to h. First of all, still we need to get the same angle. And since we have sine square in this equation, therefore you have to use this one to replace cosine 2x. We got 1 minus sine square x minus parentheses 1 minus 2 sine square x equals to 1 over 2. Then we do distributive property. You got the 1 minus sine square x minus 1 plus 2 sine square x equal to 1 over 2. Then we combine like terms. This is gone. Then we got the sine square x equals 1 over 2. This will be the power pattern. So we do square root both sides. Don't forget plus or minus. And we got the sine x equal to square root of 1 over square root of 2. That's 1 over square root of 2. Then we simplify. We got plus or minus square root of 2 over 2. Therefore, we go to all fourth quadrant, and then the reference angle, that's pi over 4. So we got pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So we write down the solution. X equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now let's go to I. First of all, make sure when you solve trig equation, we have the same angle. Angle is different here. Therefore, you have to use double trig identities to change this 2x into x. Since we are given cosine square x in this equation, you have to make sure we have the same trig. Therefore, you're using this formula. I will change cosine 2x into 2 cosine square x minus 1 equal to 0. Then I do distributive property. Cosine square x minus 3 over 2 times 2, that's 3 cosine square x. Negative square root of 2 times negative 1, that's positive 3 over 2 equal to 0. Combine like terms, you got negative 2 cosine square x plus 3 over 2 equal to 0. Since this is a power pattern, therefore you need to isolate the variable. Minus 3 over 2 both sides, you got negative 2 cosine square x equal to negative 3 over 2. Then divided by negative 2 both sides, you will get cosine square x equals negative negative will be positive, and this 2 going down. You will get 3 over 2. Then square root both sides. Don't forget plus or minus. Therefore, we got the cosine x equals to plus or minus square root of 3 over 2. Then we go to diagram. Your reference angle, that's pi over 6. Go to all 4 quadrants because you have positive or negative. Then you got the pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Therefore, your solution x equals pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6.